This is problem number 19 from chapter 11. It says, it's asking, is there a difference between the distribution of community college statistics students and the distribution for university statistics students and what technology they use on their homework? So they talk about a random selected population. So let's say community college and university would be the two different populations that we're looking at. And the distribution that we're looking at are the number of people who use computers. 43 for community college students. 102 use calculators. And 65 use tables. For university students, there's 28 who use computers, 33 who use calculators, and 40 using the tables. So these are distributions for two different populations. So it's almost like a goodness of fit test, but for more than one group. Seems a little complicated, but the good news is that the procedure that we're going to take is going to be very similar, exactly the same actually, as the test for independence. So this is a test for homogeneity, which is testing to see how similar the distributions are. But this is, like I said, very similar, exactly the same as the test for independence. So when we run the test, we're going to look for the null hypothesis and the alternative hypothesis. And we can say that for the null hypothesis, we can say that the proportions for each population for each population are the same or similar. And then you can say for the alternative hypothesis, the proportions are different. So this is your statement, your hypotheses, and then from here we go through the same process. This is a chi-square distribution test. Your distribution is going to be a chi-square sub df, whatever your df is, and very similar to the independence. It's the row minus 1, column minus 1. So we have 2 rows. So 2 minus 1 is 1 times 3 columns. 3 minus 1 is 2. So a very small chi-squared degrees of freedom value. Alright, now we go and input this data into our matrix. So let's go second function and matrix in our calculator, and we're going to edit it. And we're going to select the first one, and we put in those values of 43, 102, and 65. It's already in there. Remember, the first thing you need to do is adjust the size of your matrix, the number of rows, which is 2, and the number of columns. You can arrow or you can enter to get to the next set, and then enter again to input your data. Alright, now that we have the data in, let's go straight to our calculator's test commands and do a chi-square test. So like I said, this is exactly the steps that we take for the test for independence. We're going to have observed and expected values. Let's calculate this first to get our information. So we got our test statistic, our degrees of freedom agrees with what we had earlier, our p-value is there. So test statistic is a chi-square test, and that's equal to 7.05. And our p-value is 0.029. So it looks like this is less than our standard 0.05 for alpha, so it looks like we're going to reject the null hypothesis. The drawing, by the way, if we were to run this test again, and instead of selecting calculate, we select draw, we're going to see the drawing of your chi-square distribution. Now the chi-square distribution starts at 0 and it's skewed to the right, but with a very small degrees of freedom, it actually is very tight here and goes up. So it looks like it really is coming from the axis over there. And furthermore, our p-value is so small that you really can't see the shaded region, but there is a shaded region in there somewhere. And this is your 7.0517 value, and your p-value is a shaded region, which is 0.029 small. Alright, we rejected the null hypothesis, so we can conclude that it looks like the proportions are different. So it seems like the proportion or distribution, let's use the words I used here. It's usually good to use the words that are used in the problem. The distribution of community college students and distribution of university students in what technology they use, for their homework. Seems different. So because we rejected the idea that they could be similar, we have to look at the alternative hypothesis and say that they seem to be different. So this would be it. Alright, hope that helps with your homework.